My background is I grew up in Iowa. I grew up in a little family farm just outside of Dyersville, just northwest of Dyersville. If you know where the Dyersville Ready Mix is, which is now Bard, that was my family farm. My grandmother sold a little bit of a land off to the folks that started Dyersville Ready Mix. And now there's an ethanol plant on our farm. So the ethanol plant just northwest of Dyersville is the family farm that I grew up on. It was 128 acres, so imagine, trying to farm and make a living on 128 acres. I graduated from high school in 1984. For those of you that are old enough to remember the 80s, that was a tough time in farming and a tough time in agriculture. I was the only son of two sisters and the only son in the family, and it was expected that I would continue on farming. But in 1984, land values were $4,000 an acre, which was very high for the time. And my dad had an operating loan at the bank for 22% interest. So I can't even imagine under today's world where you could operate a farm with borrowing money to plant a crop and paying 20% interest. So anyway, so I went to school at the University of Iowa to study civil engineering. My intent was to get in the road construction industry, which I did to pay my way through school. And then as I was looking for part-time work at the university, started working at the hydraulics lab as an hourly employee and really got the interest in water-related research. And that's led to a 30-year career studying water and water-related processes. I became the director of the lab in 2004 and served as the director for 13 years. And in doing so, really made that lab, which was internationally renowned, more relevant to the state of Iowa. Now, we had a couple things happen in the 13 years of my directorship from 2004 to 2017. We had a flood in 2008 that impacted so much of eastern Iowa. I took a meeting with a group of legislators from eastern Iowa that had heard about this hydraulics and hydrology and fluid mechanics lab, and they asked, what could we do to help? And they started the meeting. State Senator Rob Hogue showed up at the meeting and he said, Director Weber, the reason we're here today is we want to stop what had happened this year in Cedar Rapids from ever happening again. And I told him, and if you know Rob, that's a pretty typical Rob statement. I said, Senator Hogue, that's a great thing to campaign on. You can make that promise, but I can't, because there was a lot going on. And of course, he had heard from his constituents that the reason the flood had happened was all because of agricultural drainage, all because of greedy land developers developing urban areas, all because of Walmart, all because of some fantasy that somebody had. We had done hydrologic study of the 2008 event, and we looked at the way that event evolved. And just to give you a little background about what happened in 2008 is that it was a unique event in Iowa. Some of you remember the 1993 flood that impacted the entire Mississippi River basin. In 2008, in the 14 days preceding the 2008 flood, we had less rainfall in Iowa than 1993, on average across our state. Less rainfall in 2008, but the Cedar River crested about 11 feet higher in 2008 than 1993. So it crested higher with less rainfall. And the reason for that is that rainfall was banded. And so it was banded across this part of the state. It was a very narrow band of very intense rainfall that created little flood waves that came out of the grassed waterways and small creeks and streams in Iowa. That water came out of those drainages and started going downstream. And then we had another very narrow but intense band of rainfall on top of that water that came out. And as that water kept moving down towards Cedar Rapids, we kept getting these very narrow, banded, intense rainfall events that put water on top of the flood wave coming out. So it was a very interesting hydrologic process that resulted in an average rainfall that was less in 2008 than 93, but water levels that rose so much higher. So we were studying that. We did a study with Iowa State to study the impact of tile drainage to try to answer that question. And when we did that study, it was very interesting to us that we went into it and there was a lot of pressure on the research for folks that supported agricultural drainage and folks that opposed agricultural drainage. and we came up with a very unsatisfying result, and that is that agricultural drainage impacts flooding. It depends. It depends on the scale, it depends on the type of rainfall, and under single storm events, agricultural drainage can reduce the impact of flooding. Under these repetitive storm events, when we have rain on rain on rain and the soil column is fully saturated, then it no longer has an impact. Okay, it no longer benefits, it no longer creates a negative impact in terms of drainage. So we did that study, not a whole lot of interest that came out of it. Agricultural drainage, on the other hand, does impact water quality. And so that we show that we have a very leaky system in Iowa, and we do these studies in the Boone River watershed. We completed a study recently, and we can show that of all the nitrate that comes out of the Boone River watershed, about 67% of it has passed through a tile drain. So that we know that it's passing through tile drainage in that watershed. So we're working on elements that really link the hydrologic cycle and the water quality cycle. My term as director, we created the Iowa Flood Center following the 2008 floods. We created the Iowa Nutrient Research Center, working with faculty over at Iowa State to really study this non-point source pollution in the state of Iowa. Those two things together led us to starting a watershed study that began about 10 years ago. And so we're going to come full circle here. 10 years ago, we started up here. Our first watershed tour was in the Turkey River watershed in Otter Creek. I remember the evening we had dinner with the folks that helped us with the tour over at Dotsey's. We followed that with ice cream up at the Barrel. So I introduced some of my students to roasted chicken for the first time up in West Union, so we had a nice time there. But 10 years ago, we started this work up in the Turkey River watershed, so it's kind of nice to be back up here today. The hydrologic work that we do is to run models, to install sensors, to try to quantify, the benefits of practices. We started that project 10 years ago in the Turkey River with $8.8 million from Housing and Urban Development. We installed about $1.5 million of practices. Many of those in this area were on-road structures where a culvert that had gotten blown out during a heavy storm event and flood event was replaced with an on-road structure that used the roadway as an embankment and backed up water onto some private land. There's an easement that goes along with that process to remunerate the landowner for the flood easement, and we study those things. We look at the positive benefit that those practices have, and we've been able to determine that with about a $1.5 million investment in these small watersheds, we can reduce the peak runoff during a 100-year rainfall event by about 20%. Okay, so about 20%. When we look at what we need across the state of Iowa, $1.5 million in a small watershed, the size of watershed that we work in, there's 1,600 of those in the state. So we have 1,600 watersheds. We've estimated on this work we need to spend about $3 million in each one of those watersheds to reduce our flood damage to a level that would be acceptable. So if you do the math on 1,600 watersheds and $3 million each, that's about $5 billion. We need a similar investment of about $3 million in each watershed to build practices that reduce nitrate runoff. So the same math applies, 1,600 watersheds times $3 million. We need another $5 billion of investment to improve our water quality in the state, to start to work towards achieving the 45% reduction for the Gulf Hypoxia Task Force recommendation. So that's another $5 billion. So we have about a $10 billion need in Iowa. We had $8.8 million. We followed that up with a $96.9 million grant that we've invested $40 million in conservation practices. But that's really just the proverbial drop in a bucket. How are we going to get there? How will we ever come up with $10 billion? It seems almost insurmountable sometimes. But if we think about it in the context of an annual investment, if we could find $200 million a year in the state and invest that in these watershed improvement projects over a 50-year period, 200 million into 10 billion is 50 years. So in 50 years, we could change the way water and nutrients come off of our land. And if you think back 50 years ago, when we were losing soil at a rate that was unacceptable and non-sustainable in agriculture, the Soil Conservation Commission came in and started working with landowners on putting in grassed waterways and buffer strips, working on changing tillage practices to reduce soil loss. We were able to reduce the amount of soil that came off of our land in the last 50 years. We could do the same with water and nutrients if we had the political will to do it. Okay? We have what's called the Iowa's Water and Land Legacy, which is a natural resources trust fund that's been in front of the legislature. The next time that the legislature would increase the sales tax in Iowa, the first 3/8 of a cent would go to fund this natural resources trust fund. That'll generate somewhere around $180 to $190 million a year. Not quite 200 million, but in terms of rough numbers, we have the opportunity to do that with IWIL. We can't do it with cost. We can't do it with cost share alone. We need practices that are on the land, and we need nutrient management on the land. And that's where I really appreciate what Lauren's doing here, what Ross is doing in this multi-cropping initiative. We need more examples of what good looks like across our state. We run these very detailed hydrologic models, and so in the case of Cedar Rapids and the Cedar River watershed, or here in the Turkey River, what we can do is at any particular point along the watershed, we can attribute all the water in the stream or the river back to the land where it came from. So we run a very detailed mathematical model that breaks up the land surface into about 20 to 40 acre parcels. So we know the rainfall on that 40 acres, we know the infiltration, we know the runoff. That runoff accumulates in the streams and goes downstream, and we can track that through the watershed. So in the case of Cedar Rapids, 140,000 cubic feet per second passed through Cedar Rapids during the 2008 flood. We can attribute that back to every acre in the landscape. We're combining that with an ag systems process model so that we can also now study how crop yields are affected by nutrient management, by tillage practices, and by cropping rotations. And some of the interesting results that come from that show that we can reduce, just by cover crops alone, if we could get high adoption, and in that case, in the Boone River watershed, if we could get 100% adoption of cover crops, we could reduce the nitrate load in that watershed by 41%. On a corn soybean cover crop implementation, we could reduce it by 41%. If we could add small grains to that rotation, we can reduce the nitrate load coming out of that watershed by 53%. So now we've exceeded the goal of the nutrient reduction strategy by including small grains and cover crops in our farming application. If we could add to that nutrient management by applying nitrate and livestock manure to the maximum return to nitrogen, the MRTN soil test that Iowa State does and recommends, then we can reduce our nutrient runoff in that watershed by 60%. So when we think about the challenges that we've had with nutrient management in the state and the struggle that we've had in getting reductions based on the voluntary nutrient reduction strategy, these are practices that could be done that, in fact, we can show with this ag systems model that do not impact yield. So we can maintain yield, we can maintain profitability by managing our nutrients and including cover into the equation. So we've been a strong advocate for that. We've been out talking to folks around the state about that work. We've got scientific evidence-based data to support it, so we're very pleased with that work. When we deploy the practices, and the $10 billion of practices that are needed, they come up well short of the benefit that we can get from a no-till cover crop rotation. So as much as we like to sell practices, as much as we like to get these practices of farm ponds and wetlands on the ground, we could do much better with a no-till cover crop rotation. So probably to about 20% adoption of the no-till cover crop rotation would be the equivalent of what we're doing with $3 million in structural practices in a Huck 12 watershed. So no-till and cover crops are a really big deal, but we got to get beyond 4%, the 4% that we're at right now in terms of cover crop adoption. There's been a lot of drainage water improvements or landscape improvements to improve drainage And, and again, I'll make this comment that, work that was done 30 and 40 years ago that was good practice at the time, maybe we look back on it and maybe we were a little too aggressive in some of those things. So, one of the elements in the modeling that we do is looking at that meandering, the sinuosity of the streams. So we can get a factor of nearly 1.6 to 1.8 in terms of additional stream length in a natural stream than we do in a straightened stream. And that 1.6 to 1.8 factor is the flushing that you refer to. So the question is, how much work have we done and how much value is there in repatriating that stream or re-meandering that stream and putting that natural cover back on. There's a huge benefit in that. And it is on that sort of factor of almost a 2-to-1 benefit in terms of slowing that water down to the rest of the stream network, holding some of that water back, and putting some of the function back in our streams. In so many cases, we've taken the function out of the small and the medium streams. Right now in Iowa, so we did a project for the state of Iowa that we created the floodplain maps for the state of Iowa. So, and in that case, rather than just modeling this 100-year floodplain map and the 500-year floodplain map, we did a full range where we did a 2-year event, the 5-year event, the 10-year, the 25, the 50, the 100, the 200, and the 500-year event. Because when I look at a floodplain, I've never gone out to a floodplain and seen a 100-year line anywhere. That's a calculated line that really has only NFIP, National Flood Insurance Program, value. There's a geologic floodplain that exists out there. But in having all of this data, we could overlay the 2-year, the 5-year, the 10-year, the 25-year. And in Iowa, we farm about 25 million acres in row crop, but we have 400,000 acres in the 2-year floodplain. So when folks, come to us and they say, geez, Larry, why do we get, more than the 100-year event happening every 100 years in the 100-year floodplain? In a similar way, the 2-year floodplain's getting flooded more than every other year. But we have 400,000 acres in the 2-year floodplain. So in 2019, when we had a major flood events all throughout the Midwest and the Missouri River was under flood stage, devastating flood. We had 53 breaches in the levee along the Missouri River, tens of thousands of acres that were flooded. The federal government came in with an emergency wetland program and wetland reserve program, and they provided $36 million of funding to the state of Iowa. So $36 million to take ag production out of the floodplain. And in the open enrollment period, they had the equivalent of $260 million of acres applied in a $36 million program. So at roughly $10,000 an acre, $36 million took 3,600 acres out of production. We had the potential of 26,400 acres that were in the open enrollment period. And because of the lack of funding, then roughly 23,000, 22,500 acres went right back into production. So that's a way, again, that we could reduce flooding, we could improve water quality, and we could have done it in a voluntary way because those landowners came into their FSA and NRCS office voluntarily and signed up for that program. We just didn't have the funding to be able to support it. Well, I mean, that means the world to me. I mean, it really does. I grew up in Iowa. I love Iowa. I've lived my whole life here. We raised our family here. I want to stay in Iowa, my entire career. We have been under attack a few times throughout the years, and as I've worked in these watershed groups, I often start the meeting by saying, I don't have an urban agenda, we don't have a rural agenda, but we do have a science agenda. And we're going to talk about some things, perhaps today, that are going to make some people uncomfortable, but we're going to talk about it from a scientific basis. And we're going to talk about it from a basis of how do we improve Iowa. There are pathways that lead us forward, but until the state of Iowa is willing to accept that we have a problem, we're going to have a harder time moving down that pathway together. There are ways to do this. There are ways to improve our water quality and reduce our flood damages and still have a vibrant and profitable agricultural system, but it's going to require that we also have some boundaries. We need some boundaries to guide some folks that aren't doing the practices that many of you are adopting. So we've got to be able to do this at scale. That's the issue that we're facing right now, is we've got to be able to do it at scale. And we've got to be able to get our legislature to start to work towards this. The unfortunate thing within the legislature is that they seem to be so heavily influenced by large industrial commodity ag groups that in some cases they're unwilling to accept any sort of boundaries or any sort of policies that would restrict anything that they do. And there's some precedent setting there. I met yesterday with the university president. Our new president started late last week and was out on campus for the first time on Monday. And so her second day on campus, she spent 2 hours with us over at the hydraulics lab in the flood center. And I talked about the programs that we have with the flood center, the nutrient center, and the Iowa Geologic Survey, and the work that we do in Iowa. And and made the point to her that if we don't do our work, if we're not doing this work, this difficult work, nobody else in Iowa is doing it. Nobody else in Iowa is doing it, and so we've got to be able to have some way to modulate this intensification of agriculture. As we continue to intensify ag across the state, we've got to be able to de-intensify it in other places. Some of those places could be the driftless area up here in northeast Iowa. Other ways to think about that are de-intensifying it in the 2-year and the 5-year floodplain. So we've got tremendous opportunity on both floodplains as well as some of the large geologic forms in Iowa. We have about 20 of these hydro stations, 22 or 23 now across the state of Iowa. They are some of the most advanced monitoring stations for this hydrologic process in the country. We have a goal of deploying 1 in every county, so we'd like to get 99 plus 1, so we can get 100 in the state of Iowa. They have a dual impact distrometer on them. So imagine a very small drum, and every water droplet that hits the drum creates a vibration in the surface, and those are calibrated to rainfall intensity. So we can monitor even high volumetric increases of rainfall or high rainfall with small droplets that come very fast, or single droplets that come very slowly. So they manage both small droplets and large droplets, and they're calibrated to that. We put 2 out there because rainfall varies so much that we always want to have 2 measuring devices to get that intensity correct. So we have the most sophisticated rain gauge, if you will, that's available to us. Then we monitor soil moisture and soil temperature at 2 inches, 4 inches, 8 inches, and 20 inches of depth. So we basically dig a little hole, and we slide soil moisture and soil temperature probes laterally off of that hole into undisturbed soils so that we're getting good data very early on. So we monitor soil moisture and soil temperature at 4 depths. We have a shallow groundwater well in each one of these locations as well, so we can monitor shallow groundwater. For us, this data is invaluable. When we start a process like including cover crops and including small grains into a cropping rotation, and now this new multi-cropping initiative that Ross has been involved in, we need to get data from the start because we need to monitor those systems over many years to see the improvement in the soil organic content that comes along, that increases infiltration and water holding capacity. So it's going to take many years of data to get that. We want to be science-based and evidence-based so that we can use the information that's created in these early adopter cases to be able to inform other systems. So we really appreciate that. This data also serves us because one of the greatest indicators of flood potential is soil moisture. So when we see the soil moisture levels rising across the state, it gives us a heightened awareness that we have the potential for flooding that's coming on. The other thing that we've learned, throughout our years of study in Iowa, is that we thought floods were really important when they impacted parts of the state in 2008, but we really realized how important droughts are to our state. Floods affect everybody along creeks and rivers and streams. Droughts affect everybody, period. And so we've had, this intermixing of floods and droughts throughout our state over the last couple of years. We've had about 1,000 presidential disaster declarations at the county scale in Iowa over the last 20 years. That's incredible from floods, but we've also seen incredible impacts of droughts as we are, again, this year in north central and northwestern Iowa where the drought seems to be persisting. We've also seen the intermixing of these floods and droughts, and so in 2013 and 14, when the drought persisted in northwest Iowa, they also had a 500-year rainfall event that spring. So they had a drought in 2013, they had a 500-year rainfall event on the Rock River and some streams in northwest Iowa, and then of course that was their one rain of the spring, and then the rainfall shut off and they went right back into drought conditions. So this is what's happening with climate change in the state. We're seeing this intensification of both floods and droughts. So we did make a request to the governor's office. The state of Iowa and the governor's office has received some funding that's come out of the economic relief and COVID relief federal funds that came to Iowa. And one of the things that we've requested is to create a drought information system that would be linked into our flood information system, and it would then expand the hydro stations across the state of Iowa so you get the soil moisture to be able to populate that drought system, and then use that in conjunction with the National Drought Forecast Center to provide increased drought forecasting for the state of Iowa. We collect data every 5 minutes. We transmit it every 15 minutes. So we have a lot of information that's out there. We have, in addition to the hydro stations, we also have, we had deployed 250 stream gauges to add to the stream gauge network that the USGS operates. The USGS is monitoring our streams at about 140 locations. The National Weather Service makes a forecast at 100 locations. We added 250 stream gauges to that network a few years ago to bring the total to about 300. And then we sent a request out to see if anybody else wanted a stream gauge, and we had 100 requests that came back in. And so we're working with the Iowa Department of Natural Resources to continue to expand that network. So we've added about another 35 in this last year. So soon we'll be 250 and 150. We'll be close to 450 stream gauges in the state of Iowa. So it's the most monitored stream network in the nation. We also, hear a lot of criticism from, some groups that say we're not doing enough in terms of water quality monitoring. We do have a water quality monitoring network that we've deployed about 65 Nitrotex sensors, and those 65 combined with about 15 that the USGS has. We have 80 locations where we monitor the nitrate concentration, again, every 15 minutes, and deploy that in our water quality information system. That is the largest network of Nitrotex sensors in the nation, and currently about 40 or 45% of all the Nitrotex sensors in the country are in Iowa. So again, I think that's a fairly impressive number.